Good morning.
Good morning, sir.
So let us start our session. What is a mobile client? A mobile client is a technology designed to extend the features of a company's mobile telephone system. This technology makes it easier for an employee to separate personal and business communication while using one smartphone. So it is a technology used to extend the features of company mobile telephone system. The first function is separate a personal and business communication while using one smartphone. Suppose you have one smartphone, one devices. So it separate the personal and business communication. Manage business calls while out of the office. Transition synchronization smoothly from using a company's desktop computer to a mobile device. Any message, any data come to your company in desktop. Suppose you are not inside the office. So there should be a transition using these two devices, combining desktop as well as your mobile devices. A mobile client is designed to make it easier to integrate portable device into a company communication workflow. These are the benefit and advantages of a mobile client. Improve customization. Using a mobile client, we can perform detailed customization on how incoming calls works through a mobile device. These include but are not limited to selective silent mode, ringtone filtering, and switching easily between private and business phone profiles. So you can customize how a incoming call to your mobile phones. Maybe you selective silent mode, your ringtone filtering. You can also switch easily between private and business phone profiles. More way to communicate. A mobile client makes it easier to bridge a divide between desktop and mobile communication. For example, a mobile client allows user to take voice message from their computer or receive mobile calls as though they are inside the corporate network. Suppose you are in a corporate network and uh, this mobile client, which is a technology, allow the user to take voice message from their computers or receive mobile calls as though they are inside the corporate network. You are not supposed sitting in your seat in front of the desktop, but you can manage to take the voice message from the computers, or you can also receive the mobile calls which comes to your computers. What is smart sensor? A smart sensor is a device that takes input from the physical environment and uses built-in computer compute resources to perform predefined function upon detection of specific input and then process data before passing it on. That is, as the name suggests, it is a smart sensor. It is a sensor. It takes the device from the physical environment. Suppose temperature. Suppose temperature decreases or increases. So it senses the temperature and perform the specific task. So it takes the input from the physical environment and perform specific tasks accordingly. Smart sensor enables more accurate and automated collection of environment data with less erroneous noise amongst the accurately recorded information. So smart sensor enable to more accurate and automated collection of environment data. These devices are used for monitoring and control mechanism in a wide variety of environment, including smart grids, battlefield reconnaissance, explorations, and many science applications. So nowadays, a smart sensor plays a vital role in various fields. The smart sensor is also a crucial and integral element for IoT. One in implementation of smart sensor is as component of a wireless sensor and actuator network whose nodes can number in the thousands, each of which is connected with one of the more other sensor, that is called sensor hub, as well as individual actuator. So we have already discussed what is actuator. You see, IoT sensor which senses thermal, sound, location, which takes input from these environment, outside environment. Suppose there is a sound, it senses that. Okay, suppose there are lightning outside of your residence, a smart sensor senses it, that is there is a huge sound, and it is associated with a microprocessor which takes which which alarms and to the system, and so that it takes uh, appropriate steps. Communication capability, and there is a receiver also to receive the input and the signals. So as we discussed in previous slides, a smart sensor has three major components: a sensor that captures data, that takes input, and a microprocessor that computes on the output of the sensor. A smart sensor might also include several other components besides the primary sensor. Am I audible or any problem?
Yes, sir. May audible.
Okay. Now some message comes that I'm not audible. Now it is clear. A smart sensor might also include several other components beside the company sensor. So the component can include transducers, amplifier, excitation controls, along filters and compensation. So as we know, a smart sensor senses something or input from take the eh, outside environment, and alarm that and senses that, and that is microprocessor. After that, the work of microprocessor comes, a microprocessor that computes on the output of the sensor via programming and communication capability. And then a smart sensor might also include several other components besides the primary sensor. These components can include transducers, amplifiers, or exciting controls. These are the other component which is used to perform specific tasks after a particular input taken from the sensor. A smart sensor also incorporates software-defined elements that provide functions such as data conversion, data processing, and communication to external devices. Besides this, a smart sensor also may provide the different function, that is a data conversion, and of digital processing of any image or whatever may be, and communication to external device. It will also make a communication to external device if he senses something. So as we discussed, that is a smart sensor communicate to the external devices. It also contain integrated communication capability that enable them to be connected to a private network or to the internet. So it is also the smart sensor can be communicated or can be connected to the internet, and this feature enables the communication to external devices. The external devices will know that there is some output from the sensor, so so that the necessary steps can be taken. Let us see some example. Label sensors, uh, um, water in tank, fuel in fuel gauge. These are the example of label sensors. A label sensor is used to measure the volume of the space taken up in a container. A vehicle's gauge might be connected to a label sensor that monitors the level of the fuel in the tank. If the fuel is less or going to be empty, so it informs the rider that the fuel is going to be empty, you have to fill up now. Similarly, the water level in the water tank, suppose the water tank in your roof, and it is, suppose the motor is going on, and the water is filled up, and it senses that the level sensor senses that the water is filled up, so they automatically stop the motor, so that no wastage of water, there is no overflow of water. Temperature sensor. A temperature sensor is a sensor that can monitor a component's temperature so that corrective action can be taken if necessary. In an industrial setting, for example, a temperature sensor can be used to make sure machinery is not overheating. So, a temperature sensor senses the temperature. And for example, in a company, in industrial setting, so a temperature sensor is used to measure the temperature of a machine. If the machine is overheated, and as you know, when a machine is working, the temperature rises. So if the temperature increases and reaches a fixed point, so the temperature sensor senses it, and inform the person in charge that the machine is overheated, so that the persons can take necessary step. So it is used to uh, protect the machine from overheating. Similarly, pressure sensor. The pressure sensors are often used to monitor the pressure of gases or fluids in a pipeline. So, if a sudden drop in pressure might indicate a leak or throw a control issue. Okay, suppose a water pipe or a oil pipe, a pressure sensor senses that there is a drop in pressure. So, pressure drop means there must be a leak. So, it senses that there is a significant decreases in pressure, so that the necessary steps will be taken. It will repair that leak. So this is the pressure sensors which sensor the pressure, like temperature sensor which sensors the temperature. Besides that, IR sensor, infrared sensor, some infrared sensor such as those used in thermal imaging camera or non-contact infrared thermometer used for temperature monitoring. So your thermometer, that is non-contact infrared thermometer, basically used in COVID time. You may recall, uh, mm, that is uses infrared sensor. It senses a temperature and displays in the small screen and what is the temperature of the body of the patient. Other infrared sensor are optical sensor tuned to a frequency that enable them to see light in the infrared spectrum. This type of sensor are used in medical equipment such as oximetry device and a electronic device designed to be operated by remote control. So, pulse oximetry device is also an example of infrared sensor. Proximity sensor. A proximity sensor is used to detect location of a person or object with relation to the sensor. So in a shopping mall, this proximity sensor can track the customer's movement throughout the store. In a Basically in a store there are some area which is restricted for the customer. So this proximity sensor senses that the location of a person object to the or object relation to the sensor. So the proximity sensor can track customers movement in a store. So it can track the location, the movement of a particular person in a geographical area. Sensors and actuators, those are both associated with your robotic engineering and all basically used or no, there are also the other application also. Sensors and actuator allow robots to achieve certain tasks. Example, what the robot may need to determine include how far away there is an object, at what speed the robot is moving, if the robot is on a hill, what is the angle, if the robot is rotating, how much angle has it rotated, where is the robot and what is the direction it is going, how far it is the travel, how much power consumed, what information is being communicated to the robot. So the robot when moves, if the obstacle comes, so it senses that there is an obstacle, so that it may change its direction. So the robot may require internal and external sensor. They use external sensor and internal sensor. External sensor, as the name suggests, it senses the external thing, that is how far it from the object and where is the object. But internal senses is used to measure the robot itself. That is how much power it is consuming, how fast it is going, uh, the angle of the robot, what is the gripper is. So these are the internal sensor and external sensor of the robot. Both are used for in robot. Actuators. A actuator is a device which causes something to happen. This could be a robot movement, which is often achieved using motors. An actuator is needed to make the robot's wheels turn. So a actuator is a device which is associated with the robot's movement or the joint of the robot arm to rotate or for a robot gripper to open or close. Or it include to be let the other know what are the robot is doing. A light being turned on to indicate the robot is working. There is a light. It it's on, that is the other can know that the robot is working. Sound is being emitted so that the actuator is a loudspeaker. Sometimes the actuator will be loudspeaker so that a sound being emitted. You can listen the sounds. Communication some from so a transmitter is needed, and display a LCD displays their LCD screen for showing picture and other data. So these are actuators and sensors. Smart home appliance, the devices we are using in our home. Fast stream technologies, smart home appliance solution are used in smart house and work on smart home automation technology that uses electric power transmission where the signal have short radio frequency which use open source software, proprietary software and distributed denial of service attack. So we are using this appliance in our home. Nowadays, the washing machine, automated washing machine, also example of the home appliance. Uh, Let us take some example. What are the home smart home appliance? First is the smart lawn mower. You may seen this. You may have seen this lawn mower, lawn mower. A highly quality lawn mower need rigorous motor control and sensing, high efficiency, secure connectivity, and high reliability and robustness. So using a safe wireless connection to the smartphone, low mowers are used to easily prolonged to make it best use of their lifespan and presentation. So there you can control your lawn mower by sitting in your home using your smartphone. Uh, you take the example of your uh, AC. Also, you can remote controller by using your mobile phone. So you can also operate on AC. Then smart refrigerator. A normal quality drive refrigerator is used for high reliability and robustness, high efficiency, safe and accurate sensing. This entails the expansion of a refrigerator with the last default cycle, stable wireless connectivity. This is wireless connectivity and higher user occurrence work on smart home automation technology. It automatically frost and defrost, and if the particular temperature it uh, reaches, so it automatically defrost. So this is the example of some home appliance, smart home appliance. One is smart lawnmower, another is smart refrigerator. Okay, so all are using your sensor, smart sensor. Then come to discuss uh, PLMN. You may find a short note on PLMN, Public Land Mobile Network. The Public Land Mobile Network is the term used to describe all mobile wireless network that use earth-based station rather than satellites. Rather than satellites, it this wireless network that use earth-based stations. PLMN is the mobile equivalent of PSTN, mobile switches tech. telephone network. PSTN stands for Public Switches Telephone Network. Such a system can stand alone, but often it is interconnected with a fixed system such as the Public Switched Telephone Network. The most familiar example of a PLMN end user is a person with a cell phone. However, mobile and portable internet use is also common. So the example of PLMN is our cell phone. This is a mobile. You can travel. You have a cell phone and you can travel. And you not while traveling, there should be no drop of your communication. There should be no drop your session logout. So the mobile and a portable internet use is also common. A public land mobile network is identified by a globally unique PLMN code, which consists of a MCC mobile country code and MNC mobile network code. Okay, so basically, you know that our country has a MCC, a country code, and all the country has a different MCC mobile country code. It is a 5 to 6 digit number identify a country, and the mobile network operator in that country usually represent in the form of 001, 01 or 001. A PLMN is a part of a location area identity, public land mobile network and that location area code, cell global identity CGI and IMSI, see a PLMN code and IMSI also code. A PLMN typically offers the following service to mobile subscriber. Let us see what are the services provided by the PLMN. Emergency call to local fire, ambulance and police station. So this is the emergency call. You know that we have these features also available in our land phone, your cell phone. You can we have the emergency call to local fire station. We have their number is already there, already stored in our mobile cell phones. So you can call to local fire station, ambulance, police station in case of emergency. Besides that, voice calls to form any PLMN cellular network or PSTN. You can call, you can voice call to any other cellular network phone or landline or VOMIB. And you can also SMS services. You can send SMS services to and from any other PLMN or SIM services to original from the texting on a mobile phone, now often replaced by messaging app. So these are may be replaced, but you can send short message. uh, Besides that, we can not only send the short message, but also we can send some MMS multimedia messaging service, some audio, some video, graphics, image. You can send over PLMN services to form any other PLMN or SIP services. Unstructured supplied service data USSD to operate the specific interaction. You know that there are some USSD code, unstructured supplementary service data, which stands for USSD. So for operator specific interaction, that is dialing star hash 1001 to indicate the current balance. You also know the how much data is already you have spent or you have to spend in a day. Also, the USD code for other services, internet data connectivity for arbitrary services. So this is also via GPRS or GSMA. So you can also internet data connectivity. You can browse internet. So these are the services provided by PLMN. high speed circuit switched data. Circuit switches, we have already discussed the packet switches. The other technology which uses packet switched data. Let us discuss circuit switched data, high speed circuit switched data. So it is an enhancement in the data rate of circuit switched data in GSM network. High speed circuit switched data uses two techniques to increase the data rate. As the name suggests, high speed, so it provides high speed data data rate. It uses two techniques to increase the data rate. Those are: first, it makes possible to use more than one time slot. GSM use time division multiple access method. So you know that when we are discussing GSM, it uses TDMA, time division multiple access. Each radio channel is divided into 8 time slots. Each time slot is allocated to a different user. This makes it possible to serve 8 customers on one radio channel, because each radio channel is divided to 8 time slots. And high speed circuit switcher data makes it possible to allocate more than one time slot to a user if available. So to increase the speed, each radio channel is divided into smaller parts, and each time slot is allocated to a different user. First technique. Second technique is, the second technique used by this technique, HSCSD, is that the error correction can be adapted to the quality of the radio channel. You know that when data is traveling, the there may be a chance that the error occur due to influence by the out, outside environment. 1 0 if altered to 1, if 1 is altered to 0, that means that there should be error. So the error correction can be adapted to the quality of the radio channel. The error correction techniques is adapted here. A standard slot can carry 9.6 kbps. HSCD makes it possible to increase this 14.4 kbps. So a standard slot can carry 9.6, but HSCD, high speed circuit switcher data, make it possible to increase this to 14.4 kbps. The quality of the radio channel must be good enough to do so. So this is used to enhance the data rate. The maximum data rate of HSCSD configuration with 44.4 kbps channel coding is 115 kbps if all 8 time slots are allocated to same user. That is, if the 8, you know that more than one slot can be allocated to a user. If all the 8 slots can be allocated to a single user, so the maximum can be 14.4 into 8. So equal to near equal to 115.2 kbps. So maximum data rate to a single user can be 115.2 kbps. The main benefit of HSCSD compared to other data enhancement introduced later is that is an inexpensive way to implement higher data rate in GSM network. There is also the other method, the used for data enhancement to increase data rates, but they are inexpensive way to implement high data rate. So these modifications to make the data relatively small. Okay, so the other method where you is going, it may be inexpensive. Wireless local loops. Local loops is a circuit line from the subscriber's phone to the local central office. Okay, we have already discussed that is your uh, landline or any subscriber phone is first connected to the local central office. Then it is connected to the internet, then to global, whatever maybe, then to the remote system. So first, this local loop is a circuit line which is connected to the subscriber phone to the local central office. But the implementation of local loop of wireless is risky for operator, especially in rural and remote area due to less number of user and increased cost of installation. So if we take this local loop as wire, physically wire or cable, it may be risky and it increase the cost. It is costlier because the less number of user in rural area. So the wire local loop may be costly or may be risky also. So the solution of this problem is use wireless local loop, okay, which uses wireless link rather than the copper wire to connect subscriber to the local central office. So you should not connect from the subscriber phone to the local central office by a copper wire, by a physical copper wire or cable. Okay. Besides that, we use the wireless local loop WLL, which is wireless. It works as same as your copper wire, but it is wireless. Okay. So the solution of the uses of wireless local loop, which uses wireless links rather than the copper wire to connect subscriber to the local central office. So rather than the copper wire, we use wireless local loop. Let us see how. You see, this is the architecture. You see, there are PSTN public switches telephone network, local exchange office, you see, and we have voice, fax, modem, data, we have a home, and there is a connection to the subscriber home to the local exchange office, and then some switches function are there, and then it is connected to the PSTN, you see. So this connection is not wired from the home to the local exchange office. You see there is a arrow mark, and this is not wired. No physical copper wire is used for that purpose, for the connection. It uses wireless connection. So this is a circuit which is connected to the home to the local exchange office is known as WLL. And you see the services, voices, fax, modem, data, you can use that in your home by using any devices. And if you send to data, there must be a connection from your home to the local exchange office. and that connection is known as WLL, and this connection is wireless. Okay, let us see what are the term used in previous slide. Is you see there are some term is used in previous slide: PSTN, WANU, WASU. Let us see what are those. You see those written in the green color: WASU, WANU, PSTN, switch functions. So what are these? PSTN. We know that it is public switches telephone network, which is a circuit switches network. It is a collection of wards interconnected circuit switches telephone network. So it is connected walls interconnected switches network. So when you are sending data, your device should be connected to PSTN. Switch function switches the PSTN among various YANUs. What is YANU? Now wireless access network unit. These are the switch function which switches the PSTN among various WANUs. It stands for wireless access network unit. It is present at the local exchange office. All the local WSU are connected to it. So WANU present in the local office. You see the previous slide. WANU is present in the local office, local exchange office. And the switches function, through switches function, is connected to PSTN and WANU is connected. And WSU, which is at home, is connected to WANU. So all the local WSU are connected to it. Its function includes authentication, operation and maintenance, routing, transceiving voice and data. That is the function of is authentication. That is you, if whether you are a authorized user or not. Okay, you may you have some user ID and password, or may you have some authentication code, so that it recognize that you are the authorized user. Operational maintenance: if the data is slow, if the traffic is jam, so it also take the maintenance and the operation. Routing: as I told, if the traffic is jam, it may change the direction. If there are other direction are there, it may change the direction of the data flow. Transmitting voice and data, it is also responsible for sending voice and data also. WASU, that is wireless access subscriber unit. Subscriber unit, so it is present within the home or subscriber unit. So it is present at the house of the subscriber. It connect to the subscriber with WANU, and the power supply for it is provided locally. So the power supply is provided locally and it is connected to WANU in local exchange office, and local is connected to the PSTN. So that we are connected to the PSTN through WANU. So WASU, wireless access subscriber unit, which is available within the home, it is connected to the WANU, and W is connected to the PSTN through switch functions. And main function of WANU is authentication, operation and maintenance, routing and transmitting voice and data. Some advantages of WLL: it eliminates the first mile or last mile construction of the network connection, low cost due to no use of conventional copper wire. As we discussed, it is wireless, so uh, the cost is less because there are no use of any copper wire. Much more secure due to digital encryption techniques used in wireless communication. So it is more secure because data is encrypted from one firm to another. highly scalable and it does not require the installation of more wires for scaling it. No wire is used. So it is highly scalable. It does not require any installation. And the other service provided by WLR data service, you can send receive data. Also voice service, you can talk to other device. You can also fax service, you can also fax from data from one devices to another device if fax is enabled. And this feature is enabled, you can send the data from one to another. It has two types according to its speed. One is LMDS, high speed internet access, real time multimedia file transfer, remote access to local area network, interactive video, video on demand, video conference, telephone services. And MMDS can transmit video, voice, or data signal at the rate 1.5 to 2 Mbps and upstream. And when on downstream, 300 kbps to upstream. So these are the uh, application of WLL. 4G and 5G network. So you know that nowadays these two generation networks are used widely, 4G and 5G. Let us discuss something here, some about 4G and 5G. High speed packet access. High speed packet access or HSPA refers to a set of technologies that came about as a result of enhancement to wideband code division multiple access system. So besides the TDM, TDMA, FDMA, so this is also a division that is wideband code division. We know that CDMA, code division multiple access. Then wideband code division multiple access method, another method is there. So HSPA is composed of the high-speed downlink packet access protocol and the high-speed uplink packet access protocol. So it is two protocol is used that we know that this is a data communication protocol. It features peak data rate up to 14 Mbps downlink. So when downlink is when we are on downlinking, that is 44 Mbps and 5.7 Mbps uploading. That is uplink. MIMO techniques, MIMO communication, which stands for multiple input and multiple output. MIMO is MIMO is an antenna technology for wireless communication in which multiple antennas are used at both the sources transmitter and the destination receiver. So one is transmitter, another is receiver. The multiple antennas are used in both sources. MIMO communication sends the same data as several signals simultaneously through multiple antennas while still utilizing a single channel. This is form a antenna diversity which uses multiple antennas to improve signal quality and strength upon a RF link. You see, This is a 4 cross 4 MIMO. Receiver with 4 antennas and LTE enable, also four transmitters. And you see the radio transmission path, that is each transmitter is connected to four receivers, and similarly the one receiver is connected to the fourth transmitter. And the benefit is improved throughput, high data rate, increased coverage. You see how. When you send data over these techniques or over this communication, this data is split into multiple data streams at the transmission point and recombined on the received side data by another memory radio component with the same number of antennas. Okay. Suppose let's take an example. Suppose you are sending data 40 MB and there are four antennas and the data is split into multiple data stream. Suppose the data is divided into four equal parts, 10 KB each, and it is sent to at a time from the sender to receiver. And receiver side, when it is reached, it is recombined again, so that your data takes less time. That is, simultaneously, parallelly, you send data 10 KB each. You need not to wait for 40 KB or 10 KB, then 10 KB, then 10 KB, then 10 KB. So if 40 KB data are sent in series one by one, it takes more time. So here data is splitted into smaller parts, then sent simultaneously, parallelly. Okay, so same thing is written as you see here. The data is split into multiple data streams at the transmission point and recombined on the receive side by another MIMO radio configured with the same number of antennas. So the receiver is designed to take into account of slight time difference between receptions of each signal, any additional noise or interface, and even lost signals. You see here, there are the receiver, there are the transmitters, and data are sent with different four connections. Four paths are there, you see different transmission path. So the data is split into four parts and sent to the receivers. Receiver receive it and they are only recombined. So the benefit you will get is improved throughput, obviously high data rate, and increased coverage. The next topic is WiMAX and LTE. The worldwide interoperability for microwave access is a telecommunication technology aimed at providing wireless data over long distance in a variety of ways, from point to point links to full mobile cellular type access. WiMAX and LTE are both wireless network technology suitable for data connection to mobile devices. So both are the wireless technology and suitable for connection to mobile or sometimes stationary devices. And it is a WiMAX is an IEEE standard 8021.6. Its original name is wireless MAN for Metropolitan Access Network. You know that MAN, LAN, MAN 1. The name appears intermittently in the IEEE standards. So it is a IEEE standards 80.21c standards. Its original name is wireless MAN, and now it is known as WiMAX. LT. This is first introduced in 2008. It defined in a new cellular access network with high spectral efficiency, high peak data rates, short round trip time, as well as flexibility in frequency and bandwidth. It signifies an evolving level of performance as the capability of cellular hardware, software, and network technology, such as speed, latency, battery uses, and cost efficiency. So this is a high performance in cellular hardware. Speed is more. Latency means the data send and data receive. The time gap between the data send and data receive, that is called latency. Battery uses, less battery uses, and cost efficiency. So these are the features of LTE. Besides that, LTE technology has delivered multiple benefits worldwide. LTE connectivity is almost universally available around the world for both consumer and commercial industry applications. These are available universally. LTE provides long-term network continuity as older networks such as 2G and 3G sunset. So after 2G and 3G, the LTE technology used widely. In regions where 5G will not be available for sometimes 4G LTE or 4G LTE Advanced and 4G LTE Advanced Pro technology will support migration needs from 2G, 3G for years to come. So before 5G, 4G LTE, 4G LTE Advanced, 4G LG Advanced Pro technology are used. LTE offers higher speed as well as significant benefits for low power applications and simpler low cost devices, providing a single technology foundation for a wide variety of use cases. Let us see how LT works. LT offers lower latency. Lower latency means the time gap between the data sent and data received. That is lower latency means it takes less time and increases throughputs the network, dramatically improving upon 3G network performance. The data rate are high as compared to the 2G and 3G. LTE operates on a separate spectrum from 3G network and requires new hardware. LTE provides fast data download speed of several hundred megabytes per second Mbps compared to several tenth Mbps for 3G, meaning that LTE is 5 to 10 times faster than 3G. So as you know, after 2G and 3G, the LTE technology is used. If we compare the LTE technology with the 3G technology, it is 5 to 10 times faster. LTE can support data, voice, instant messaging, and video on smartphone and tablets over a single interface. With 3G, this was done over different systems and on some networks, voice and data was mutually exclusive. That in some network, data and voice are mutually exclusive. Mutually exclusive means they can use one by one. So if we differentiate between 3G and LTE, The first major component must be speed. Obviously, 3D is slower with data rates measured in kilobytes rather than the megabytes per second. But LTE is the data rates in LTG as compared in Mbps. Latency. Actually, here is bad weather, so the power is not there. So I also I there is no backup. Also, I don't have any more backup. So the second is a latency, 3G latency. As we discussed, the latency, the time gap between when the data is sent and it is received, and is much greater. The 3G latency is much greater. That is, that takes more time. It takes more time from the sender to receiver. Power uses LT device transfer a higher volume of data and can therefore use batteries faster than 3G, which has cost and power management implications that developer and network manager also take into consideration. So as it is sends or transfer higher volume of data, so obviously it needs more power. So there are more battery uses and it consumes more power as compared to 3G. So you can tell this is a drawback of LT technology. Availability and reliability. 3G involves until recently were more widely available. Today, 4G networks are nearly universally available and the reliability difference have already happened. So 3G networks until recently were more widely available. So this is all about your 3G and LT. The difference between LT and 3G in place of speed, LT has more speed. Latency, 3 latency is greater, but LT is smaller latency rate. LT device needs more power, and 3G network until recently were more widely available. So 4G network were nearly. What is ultra wideband? UWB. UWB is a short range wireless communication protocol that is like a Bluetooth or Wi-Fi, use radio waves, but it differs substantially in that it operates at a very high frequency. As its name denotes, it also uses wide spectrum of several gigahertz. 5G generation mobile network, it is a new global wireless standard, and nowadays it is widely used. After 1G, 2G, 3G, GSM, it enables a new kind of network that is designed to connect virtual everyone and everything together, including machines, objects, and devices. 5G wireless technology is meant to deliver higher multi-Gbps peak data speed, more reliability, massive network capability, increased availability, and more uniform user experience to more users, higher performance and improve efficiency, empower new user experience, and connect new industry. These are some features. Enhanced mobile broadband, more uniform data rates, obviously lower latency and lower cost per bit. 5G, massive critical communications. 5G can enable new service that can transform industries with ultra reliable, available, low latency links like remote control of critical infrastructure, vehicles, and medical procedures. So this is used different areas. 5G is meant to seamlessly connect a massive number of embedded sensors in virtually everything through the ability to scale down in data rates, power, and mobility, providing extremely lean to low cost connectivity solutions. So then mobile IP, let's talk there. This is an important topic, mobile IP, how the mobile IP works. As we have a small discussion about mobile IP in previous classes. Uh, the, we know that the mobile IP enables a node to continue its communication while traveling in a high speed vehicles. So when we are traveling in a vehicles or a high speed vehicles, you may pass you may pass from one network, you may leave from one network and enter a new network, but your communication will not be dropped. Your communication will be not be dropped. This is the work of mobile IP. Please recall we have discussed some terms of mobile IP: the home agent, the home network, the foreign agent, foreign network, the correspondent node, the correspondent address, tunneling. We have already discussed in previous classes. So we had a brief discussion here. The correspondent node means that the mobile or the device which sends data to you is known as the correspondent correspondent node. Data packets contain the corresponding node address and home address. Packet reach the home agent. So when a message come from you from a device that is known as here correspondent node, it does not contain the data does not contain only the data itself. It also contain the address of the source, also the address of the destination. It is exactly like when you send a letter. When you send a letter to your relatives, to your friend, not only the letter will be sent, that packet also contain the destination address as well as source address. So when it reaches the home agent, and if the mobile are available in the home network, so there is no problem, the direct data will be delivered. But the problem is, suppose data is reach in the home agent, but the mobile node is not available in home in that network. So if the mobile node is not in the home network, it has moved into a foreign network. So the foreign agent send a care of address to the home agent to which all the packets should be sent. So when you are traveling from one network to another network, from your home network to your foreign network, the foreign agent immediately send an address known as address for correspondence, COA. That is called care of address also, COA, care of address, to the home agent that if any data comes from this address, please send to me, because that mobile node is now available within my network. So now a tunnel will be established between the home agent and the foreign agent by the process of tunneling. A dedicated path, which is termed as here tunnel, will be established between the corresponding node and the mobile node. Okay. You see the picture first, you see there the corresponding node, you see, which is written as CN. Now CN is sending data to a mobile node, which is comes to the home agent of that node. So see now the correspondent node sending data to the home agent. If the mobile node within present in that network, the home network, there will be no problem for the home agent. Home agent will direct deliver that. Will be not a problem for the home agent. But unfortunately, the mobile node is traveling to here. You see, MN. MN stands for mobile node. The mobile node is not present in the home network. Now it is come to the foreign agent, foreign network. Okay. So the foreign agent already informed to the home agent that your mobile node, which is belongs to your network, now comes within my network, and this is a care of address, COA. If any data comes from it, please send to COA. So if the corresponding node now sends the data to mobile node, the home agent knows that the mobile node is not available within my network, but it is available in foreign agent. I have its COA. So in this time, a tunnel. You see, there's a tunnel. The red color a tunnel is established between the home agent and the foreign agent, and through that tunnel, the data will send to the foreign agent directly. So now foreign agent receive the data from the home agent, and it now forward the data to the mobile node, because the mobile node is now available in its network. So it delivers the data to the mobile network. Okay. So mobile node gets its data and sends an acknowledgement to the foreign agent. Sends an acknowledgement to the foreign agent that it received data, and then the foreign agent directly send that acknowledgement to the corresponding node. You see this arrow. Now it does not use the tunnel again to send the acknowledgement. It directly send the data to the corresponding node. Now the question arises, how does the foreign agent know the address of corresponding node? You know that when sending data, along with the data, the destination address, source address, and the data are available. So the data which are delivered to foreign agent through the tunnel, it not only contain the data itself, but also it contains another two address: the foreign address, sorry, the receiver address, the sender address. Sender address means the corresponding node address. Receiver address means the mobile node address. So the foreign agent know the receiver, the sender's address. So it directly send the data to that network, to the corresponding node directly. Okay. So this is the procedure of mobile IP.
So
So
what if the
some
address is incorrect? Then in that case, what will happen? Any
sorry,
of the
sorry,
case, like
sorry.
what if the any of the address is incorrect? In that case, what will happen?
If the address is incorrect,
Yes, sir. If yeah, yes, sir.
no, no. If the address is incorrect, that is the error correction and detection mechanism. That is, it mean to say that that is the along with the data, the sender address and the both are available. Okay, so how does the address be wrong?
In case address is not found, like to the home
How
address.
it is comes along with the data, na? During tunneling the process where data is delivered from one end to another end. It is a dedicated path. As it is a dedicated path, so data which data is come from the home agent, it is contain the data. That packet contain the data, the source address and receiver address.
That's
So
why I'm
how
saying,
it is?
like if
How is it
in
missing?
any by chance, yes, if by
If
chance
by the missing, that is
and
the technique will be others. That is there will be the data will be again sent to the home agent again, and there should be error and error correction and detection method to receive the data again. So if there is something is missing, the data will not be delivered.
okay.
It would follow the other techniques, other methods.
So is it going to be stored in the foreign agent, or it will not send to the home
No,
address?
it is not sent. That is the acknowledgement will not sent. Although the data will
Okay.
be sent, if there is no address of the sender, so acknowledgement will be not be sent to the senders.
If we take a WhatsApp example, if I'm sending a message to the home address, so in case the address is not like the if he's like the home address is online, so
Hmm.
like the message will be the data will be the message or the data will be sent to the home address, home agent in that
Hmm.
case, or if I will receive the acknowledgement as well, that blue tick that comes, that the message
No, no.
has been delivered. Yeah.
Suppose the address is not found, so WhatsApp uses the other techniques. WhatsApp other technique. That is, it has some buffers, maybe contain some address. Okay. So it may be contain on the other techniques. Okay. But here the data is the sender data is not found, so there should be the problem that the acknowledgement will be not sent. Other technique will be done. That is, it will data should be sent to the receiver. The receiver will get it, but there will be a problem while sending the acknowledgement. Okay, the sending data will be only used for sending the acknowledgement.
Sure. Okay,
Okay.
sir.
So during the whole process, the three mechanism can be done. One is agent discovery. That is agent advertisement their presence by periodically broadcasting the agent advertisement message. The mobile node receiving the agent advertisement message observe whether the message is from its own home agent or determine whether it is in the home network and foreign network. So agent registration also we have already discussed. That is when you enter a new network. So the foreign agent and the home agent have an agreement, that within by sending a COA, care of address. And the last, it is important, tunneling. That is, it establishes a virtual pipe for the packets available between a tunnel entry and tunnel endpoint. This is important. Tunnel entry and tunnel endpoint. It is only enter the data from the one end and receive another end. There is no other intermission or interfere in between that path. This is a dedicated path, virtual path. It is the process of sending a packet via a tunnel, and it is achieved by a mechanism called encapsulation. Okay, encapsulation. It takes place to forwarding an IP datagram from the home agent to care of address, where the home agent receive a packet from the correspondent node. It encaps the packet with sources address and home address and destination and care of address. Okay, so as you told, in case missing, so this is encapsulate that. It encapsulate feature, you know. So the data, the home address and the foreign address are encapsulated. The source address, destination address, and the data. So the chances of missing the address is less or rare.
Okay, sir. I now understand. Like before sending the data or message, the agent is identified or agent registered. Then only we can send the message. Then we
Yes. While sending data, our home agent encapsulate. That is, it binds the data, home address, and in one unit. That is encapsulation property. You recall from the OOPS.
Yes, sir. I know.
Hmm. So so there will be a very less chance the data should be lost because it is a dedicated path and data is encapsulated. The home agent encapsulates the data packet into new packet in which the source address of the home address and the destination is the care of address and set it through the tunnel of foreign agent. The foreign agent on other sides of the tunnel receive the data packets, decapsulate it, and send them to the mobile node. The mobile node, in response to the data packet, receive the sends and reply to respond to the foreign agent. So it send the acknowledgement and send a reply, and the foreign agent directly send the reply to the correspondent node. There is no need of tunneling again because you know that the address of the correspondent node. So directly send the acknowledgement. Then route optimization. The route optimization add a conceptual data structure for binding cache to the correspondent mode. As the name suggests, route optimization, we always prefer a shortest route when we are traveling from our source to destination. So similarly, the mobile IP has some techniques to choose a shortest path from the source to the destination. The binding cache contains binding for the mobile nodes on home address and its current care of address. Every time the home agent receives an IP datagram that destines a mobile node currently away from the home network, it sends a binding update to the corresponding node to update the information in the corresponding node's binding cache. After this, the corresponding node can directly tunnel packets and mobile IP is provided by the network providers. So this the mobile IP also used for the route optimization. So this is the work of mobile IP. So mobile IP enable us to communicate, to continue our communication while we are traveling, even though a high speed vehicles. Okay. So there are no drop of communication. So we should not stop our communication. This communication will be continued. So this is the function of mobile IP. So cellular IP we'll discuss in the next class. So please write your name and registration number in the board for attendance. Please do not repeat. Those who have not written, please write now your name and registration number. 1 minute.
Yes.
I will take your.
Any questions? Any query?
Please wait 1 minute. I will take the snapshot. Okay, now you can leave. Thank you. Thank you to all. Meet in the next class.
So, do you have any idea of Viva? Like the
No,
coming
no,
Viva,
no,
because it is yet to
no, no. I don't have
be.
any idea. You may contact to the LC or Tushar. Tushar, jo the contact person. So you may contact him for all details.
From like married only, or some.
Merit, merit.
Okay, Tushar sir. Okay, I'll contact him.
Okay,
Sir,
okay. Thank you. Bolo.
yes, sir. One more thing, like in yes, sir, like as we are studying this topic, mobile computing and computer, sorry,
Hmm,
uh, computer vision, so
hmm,
digital image processing and computer vision. So these are
hmm.
two different topics, or like we
There are two
have.
different topics. There are two different
Yes, sir.
topics. That is your digital DIP. That is computer vision comes from DIP.
Yes, sir.
Okay,
So
and this is
the
a mobile
questions,
communication.
what will be the weightage? Like both have the same weightage, or in exam point of view, or they have a two different sections. The question, how will the question comes into in your
You
examinations?
may follow the older questions, the previous question papers. Do you have any previous question papers?
It's in the website. I can go and check. Just I want to know, like
You can
what.
check and see the previous question papers. That is question comes some applications, and you will get some question directly, and some question comes that is some numerical. In DIP, you know that there are a number of numericals. I have already provided the slide. You go for the slides. You will get more questions.
Sure, sure, sure. And so, what kind of project we can work on using DIP
Actually,
and
the
computer
project
vision?
uh, you can though nowadays there is a widely range of DIP, image processing, machine learning, computer vision. This is now trend is going on AI and machine learning. Okay, so you can take any project in a small project. Okay, not a complex project, a small project to machine learning and AI or deep learning. You can take the deep learning in project. And I think the RK Datta sir will be taken your project class.
Yes, sir. Yeah, RK Datta sir is there for the
So you
project.
can contact. Yes, you can contact him and discuss with him.
And sir, what are the scopes of learning this computer vision and DIP? Scopes, like in
Uh,
terms of career, like what kind of
no, no.
career
Actually,
opportunities we have?
this syllabus contains basic things. Actually, the
Yes, sir.
syllabus we have learned, and you know that there are only 6 classes to complete your session. Okay,
Right.
so I have discussed the basic things and some important things that is related to your exam only.
Yes, sir.
Okay. So there is a large scope of machine learning and your DIP nowadays, deep learning, computer vision. So it is a huge scope, and the trend is going on over that AIML. In,
Yeah, sir, yeah. Of
mm,
course, like the curriculum we have is very basic, and things are
mm,
now
mm,
advanced.
yes, yes.
Okay, sir. Thank you so much
Okay,
for your
okay.
time.
Thank you. Let us leave.